So good morning, everyone. I'm Felipe, and today I'm presenting a work I have written with Maia and Emerson. And our work's title is Predicting Legal Proceedings Status Approaches Based on Sequential Text Data. So basically, our main objective here was to develop a predictive model to classify Brazilian legal proceedings in three possible classes of status. So a proceeding could be archived, active, or suspended. And this problem's resolution can help public and private institutions to handle large portfolios of legal proceedings, providing gains in scale and efficiency in their operations. So let's talk about our data. So before we talk about the data sets themselves, we should say that each proceeding in our case is made up of a chronological sequence of short texts. So we are basically dealing with a sequence of text classification. And we have two data sets. The first one is a data set of around 3 million unlabeled texts that we use to train our unsupervised language models. And the second data set is a data set containing around 6,500 labeled legal proceedings, each with an individual and variable number of texts. And these data sets are sampled from the first and third biggest Brazilian state courts, São Paulo and Rio de Janeiro. So let's talk about our classification strategies now. Given that each proceeding has a variable number of texts, we should set a threshold. So we chose to work with the last 5 texts. And in order to classify the sequence of texts, we combined 4 feature structures with 3 classification architectures. By feature structures, we mean language models. And they are Word2Vec, Doc2Vec, TF-IDF, and a Brazilian Portuguese BERT-based model. As classifiers, we used multi-layer perceptrons, LSTM neural nets, and an XGBoost classifier. And while LSTM can naturally exploit the temporal structure of the sequence of texts, and when using the multi-layer perceptrons and the XGBoost classifier, we had to concatenate the last 5 text representations to have a unique vector of features for each sequence of texts. And here we have our basic results, classification results. As you can see, the best results we got when using the combination of LSTM with Word2Vec, using a convolutional layer to extract features from each text, and LSTM and BERT. So now that we have talked about the classification itself, it's interesting to talk about interpretability, how we use our models to make interpretable insights. And when using the LSTM combined with the Word2Vec representation, we're actually using a convolutional layer to extract features from each of the texts. So we have the LSTM, CNN, dash Word2Vec architecture. And using this architecture is very convenient for us because we can, after training our model, we can interpret the convolutional filters, comparing their final configuration with tokens in our vocabulary. So we can see what kind of patterns the neural network is searching in our texts. So basically, we take a look at the embeddings representations of tokens closest to representations of 3 out of 9 filters. For example, here we have filter 6. So it says when you can see that it says that when a proceeding is going to be archived or is archived. Filter 7 is related to the archived and suspended classes, while the filter 8 doesn't seem to be related with any of the classes at all. And we can confirm our intuitions looking at this plot here. So for example, these are partial dependence plots. And looking here, for example, in filter 8, you can see we have basically flat plots. That means that filter 8 doesn't have a relationship with any one of the three classes, while filter 6 and 7 have a very strong relation with the outputs model for class 1, 2, and 3. So this was our work. The full version can be found on archive, and here are contacts. So thank you very much.